In this video, we're going to look at another example of trigonometric substitution. This will be a secant substitution. Here we have integral root of 9x squared minus 25 divided by x cubed integrated with respect to x. So we notice the numerator is root of 9x squared minus 25. That is variable squared minus constant squared. We can write 9x squared minus 25 as 3x all squared minus 5 all squared. Alright, so the pattern that we have is root of u squared minus a squared. Variable squared minus constant squared. The transformation that will apply is a secant transformation. U is equal to a secant theta. Take its derivative, du is equal to a sec theta tan theta d theta. Derivative of sec theta is sec theta tan theta. So the numerator of the integrand is root of 3x all squared minus 5 all squared. The trig substitution will apply is 3x is equal to 5 sec theta. Differentiate both sides, we'll get 3 dx is equal to derivative of secant is sec theta tan theta. So we get 5 times sec theta tan theta d theta. Divide both sides by 3, and the 3 cancels out, and we get dx. Alright, so what we have is root of 9x squared minus 25, that's the numerator. We can rewrite that as root of 5 sec theta all squared, that is 3x all squared, that gives you 9x squared, minus 25. Now factor out the 25 inside the radical, we get 25 times sec squared theta minus 1. Now let's remove root of 25 and bring it outside the radical, so we get 5 root of sec squared theta minus 1. Now, what is sec squared theta minus 1? We have a trig identity, 1 plus tan squared theta is equal to secant squared theta. So sec squared theta minus 1 is tan squared theta. And that's exactly, this identity is exactly the thing that allows us to get rid of the radical. We get rid of the root sign. And that makes the integration possible. So we get 5 root of tan squared theta. Root of tan squared theta will be absolute value of tan theta. That's 5 times absolute value of tan theta. But because of the way we have restricted the angle theta, we can remove the absolute value. So we get 5 tan theta. We have shown that the numerator of the integrand, root of 9x squared minus 25, is equal to 5 tan theta. The denominator of the integrand, x cubed, is equal to 5 over 3 secant theta all cubed. That gives us 125, because 5 cubed is 125, divided by 3 cubed is 27, times secant cubed theta. Alright, so what we have is integral root of 9x squared minus 25 divided by x cubed, and we did a trig transformation. 3x is equal to 5 sec theta, so x is equal to 5 over 3 sec theta tan theta. We differentiate both sides, we get dx is equal to 5 over 3 sec theta tan theta. I need to make a correction here, so let me fix this. We have x is equal to 5 sec theta divided by 3. Now differentiate both sides, we get dx is equal to 5 over 3 secant theta tan theta d theta. And root of 9x squared minus 25, that's the numerator of the integrand. We showed earlier that this is just equal to the trig function 5 tan theta, and the denominator of the integrand x cubed, we show that that's equal to 125 divided by 27 secant cubed theta. So what we have shown is that the integral root of 9x squared minus 25 divided by x cubed dx is equal to the following trig integral. 5 tan theta, that's the numerator root of 9x squared minus 25. The denominator x cubed becomes 125 over 27 times secant cubed theta, and dx becomes 5 over 3 sec theta tan theta d theta. Now let's remove all the constants and organize everything. So we get 25 over 3, 5 times 5 is 25, times 27 over 125. Because we have 1 over 125 over 27, and it flips, we get 27 over 125. Integral, we've got tan theta here, and we've got tan theta here. That gives us tan squared theta times secant theta divided by secant cubed theta d theta. The sec theta in the numerator cancels with sec cubed, giving us secant squared in the denominator. So what we get is, if we simplify, we get 3 cancels with 27, that gives us 9, and 25 cancels with 125, that gives us 5. So we get 9 over 5 integral tan squared theta divided by secant squared theta d theta. Alright, so what we have is the integral root of 9x squared minus 25 divided by x cubed dx. That's equal to 9 over 5 times tan squared, 9 over 5 times the integral tan squared theta divided by sec squared theta, integrated with respect to theta. We're going to use a trig identity and write tan squared theta as secant squared theta minus 1. So we get 9 over 5 integral secant squared theta minus 1 divided by secant squared theta d theta. Let's split up the fractions, and we get 9 over 5 times the integral secant squared theta divided by secant squared theta is 1 minus 1 over secant squared theta, all integrated with respect to theta. So we have 9 over 5 integral 1 minus 1 over secant squared theta is just cosine squared theta d theta. Now we have to use a half angle identity and change cosine squared theta so that we can integrate this. So we get 9 over 5 integral 1 minus cosine squared theta is 1/2 times 1 plus cosine 2 theta. So that's 1/2 times 1 plus cosine 2 theta, all in brackets, d theta. That gives us 9 over 5 integral 1 minus 1/2 gives us 1/2 minus 1/2 cosine 2 theta, all integrated with respect to theta. That gives us 9 over 5 integral. Let's solve the integral. So we get, what do we get? Well, we have integral 1/2. That gives us 1/2 theta minus 1/2. What is integral of cosine 2 theta? Well, if it was cosine, integral of cos theta would be sine theta. But we have cosine 2 theta. That means we have to use U substitution. Let U be equal to 2 theta. du is 2d theta. So integral of cos of 2 theta will be sine 2 theta divided by 2. And that's just reversing the chain rule. Plus c. Now we're going to use a trig identity as sine 2 theta. The double angle identity is equal to 2 sine theta cos theta. So what we get is 9 over 5 times 1/2 theta minus 1/2 times sine 2 theta, which is 2 sine theta cos theta divided by 2 plus c. So you can see with the cancellation, we get 2 cancels with a 2. And so what we have is 9 over 5 times 1/2 theta minus 1/4 sine 2 theta plus c. Of course, we have to bring this back to the variable x, but before doing that, let's rewrite this. 9 over 5, 1/2 theta minus 1/4 sine 2 theta is 2 sine theta cos theta plus c. We simplify this, we get 9 over 10 theta minus 9 over 10 sine theta cos theta plus c. Now we can't just stop there, we have to express the result in terms of x. And that's where we have to introduce the reference triangle and change everything back to x. So what we have is secant theta is equal to 3x over 5. And our transformation was 3x is equal to 5 secant theta. Sec theta is 3x divided by 5. That's hypotenuse divided by adjacent. So let's create a right angle triangle. Here's theta, here's 90 degrees. Sec theta is hypotenuse over adjacent. Hypotenuse is 3x, adjacent is 5. Now apply Pythagoras and solve for the missing side. We'll get root of 9x squared minus 25. So we're going to need theta, we're going to need sine theta and cos theta all in terms of x. So what is theta in terms of x? Well, theta, that will be easy. Just take inverse secant of your substitution and we'll get secant minus 1 of 3x divided by 5. What is sine theta? Sine theta, that's going to be opposite over hypotenuse. And let's look at a triangle, and that's going to give us 9x squared minus 25 divided by 3x. Let's look at cosine theta. That's equal to adjacent over hypotenuse, 5 over 3x. All right, so let's label this reference triangle. This is very important. It allows us to bring our answer back in terms of x. And so what we have shown is integral root of 9x squared minus 25 divided by x cubed dx is equal to 9 over 10 theta minus 9 over 10 sine theta cos theta plus c. And we showed earlier that theta is equal to sec minus 1 3x over 5. We applied the reference triangle and we got sine theta to be equal to root of 9x squared minus 25 divided by 3x, and cosine theta is equal to 5 over 3x. So we're now ready to get everything back into the variable x. So what we have is 9 over 10 times theta. Well, theta is secant minus 1 of 3x divided by 5 minus 9 over 10 times sine theta. Sine theta is root of 9x squared minus 25 divided by 3x times cosine theta. Cosine theta is 5 divided by 3x plus c. If we simplify this, we're going to get 9 over 10 secant minus 1 of 3x over 5. And if we manage these constants, we've got 9 times 5 in the numerator, that's 45, divided by 90, that gives us 1 over 2. So we get negative 1 over 2. And we've got x times x, this x times this x, that gives us x squared. And in the numerator, we've got root of 9x squared minus 25 plus c. That is the answer to this integral. Now, let's also talk about some of the trig identities that we applied earlier. So these are things that you should really memorize. So 1 plus tan squared theta is secant squared theta. We applied this one. We also applied cosine squared theta plus sine squared theta equals 1. We also applied the double angle identity, sine squared theta. Sorry, sine 2 theta is 2 sine theta cos theta. And the next one is sine squared theta is 1/2 times 1 minus cosine 2 theta. Derivative of sec x is equal to sec x tan x. And we also did a U substitution, but because it was easy, we just did it mentally. So integral of cos 2 theta, d theta, we do a substitution, let u be equal to 2 theta, du is 2 d theta. So if you solve for d theta, you get d theta is equal to du over 2. And the reason we have a 2 here is exactly because we have a 2 here, because d theta is 1/2 du. All right, thanks.